All right, so we're going to dive into 13.2 together, and I thought I would make a little cameo appearance. I rarely am in these videos, just my screen, but I wanted to show you something that would be hard to do on the screen. And so I've cut out a little piece of paper, and I want you to imagine with me that this piece of paper is the area under a function, under a curve f of x in the xy plane. And so maybe this is the x-axis, and this is the y-axis. Of course, I'm flipped. It doesn't matter. I'll let you orient however you need to. We're going to assume that these holes are not there. You can fill those in and assume this is perfectly flat. So I want you just to think for a moment. I'm not sure how to hold this where you can see it. I want you to think for a moment, how would you compute this piece of area? You can pause the video if you want to think about it. Well, you would set up a definite integral, right? You would say, well, this is a function of one variable, so I would integrate from a to b, and I would take the integral from a to b of this function f of x, and I can interpret that as the area under f, and that's how you do it. So my question for you now is, am I changing the area when I do this? No, right? It's the same area, but now it's quite different. I've taken it, I've bent it. Now it's in 3 space. And so would your previous technique work to compute this area? And the answer is no, right? To model this, you're going to need to involve 2 or 3 variables, whereas in calculus, we work with 1 variable, back in Calc 1. So what we're going to do is we're going to imagine a curve in the xy plane. That's the bottom curve where my thumb is. And I'm going to imagine a function of 2 variables over the xy plane, a big surface, so not just this part. But if I took the curve in the xy plane and I drew a fence, I made a wall from my curve C at the bottom of this. I need more hands. I don't have enough hands here. And I go up to my surface, I would get a wall that looked like this. And so we're going to be able to interpret one of the kinds of line integrals we're about to learn in this way. You can think about a certain kind of line integral as the area of a curvy wall like this, where the top of your wall is a surface given by a function of 2 variables, and the bottom of your wall is a curve in the xy plane. So hopefully this helps a little bit, and let's go ahead and go back to the screen and dive into 13.2. Take care.